Hello and welcome again to another video in our series 105. This is part 2 of the air conditioning process. In our last video we talked about the condensing unit and the refrigeration process and the condenser. Now we're going to go into the evaporator. So entering into our metering device, our liquid line coming from our condenser, as we have stated in the last video, is a high pressure subcooled liquid. We had a saturation temperature of 120 degrees. We've subcooled 10 degrees. So the refrigerant in this liquid line is a high pressure that's at 110 degrees, 10 degrees of subcooling. That enters into our metering device, and in the metering device, the purpose of the metering device is to regulate flow and drop pressure. So its purpose is not to add or take any heat away from the refrigerant, but strictly to reduce the pressure to our low pressure operating point and to regulate the refrigerant flow. So there are several types of metering devices, and we'll talk about those later on. For this purpose, a metering device is just going to be a restrictor. It's just an orifice to drop pressure. So the refrigerant entering into the metering device is a high pressure subcooled liquid. In the metering device, it is going to drop pressure. The refrigerant leaving is going to be a low pressure saturated liquid. So it will be at its boiling point. It enters into the evaporator coil where it's going to absorb heat. That heat that it's going to absorb will be latent heat, which will cause a change in the state of the refrigerant. So it will boil, and it will boil at its saturation temperature, which in this case is 40 degrees. So as it's boiling, it's absorbing heat. It's absorbing a lot of heat, and when that refrigerant completely boils, it is 100% saturated vapor, but it's still at 40 degrees. Then it begins a superheating process. That is the last part of the heat transfer cycle in the evaporator. The refrigerant leaving the evaporator will be a low pressure, superheated vapor that has a saturation temperature of 40 degrees, which has had 15 degrees of superheat added to it, so it will be 55 degrees, leaving the evaporator, entering into our condensing unit. So to review this refrigeration process, we leave our evaporator coil as a low pressure superheated vapor, saturation temperature of 40 degrees with a 15 degrees superheat, enters into my compressor where the compressor is pumping the refrigerant, raising the pressure, and it is adding some heat in the process of compressing, and it leaves as a high pressure superheated vapor through my discharge line. That goes into my condenser coil where I begin my first stage of heat rejection, which is going to be removing the superheat from that vapor. And then I'm going to condense the vapor at its saturation temperature, which is in this case 120 degrees. And then once I've removed all of the latent heat, it's all condensed into a liquid. Then I will subcool that liquid, and in this case that was 10 degrees. So leaving my condenser, I am a high pressure subcooled liquid that has a saturation temperature of 120 and is subcooled to 110. That then goes into my metering device where I will drop pressure and regulate flow. I drop my pressure to my low pressure state, which will be a 40 degree saturation temperature. I enter into my evaporator coil, boiling at 40 degrees. The refrigerant is going to boil. Then when it's all boiled off, then it's going to superheat, and in this case it will superheat 15 degrees. So leaving my evaporator coil, I will be a low pressure superheated vapor that has a saturation temperature of 40 degrees with a 15 degree superheat. Please watch the next video. We will talk in more detail about this process and how subcooling and superheat affects the system operation and how the system operation can affect subcooling and superheat. Thank you.